All right, CNT125, Chapter 8, we're continuing our discussion on VLANs. Again, these are virtual, these are logical. So the next point they bring us is VLANs can include ports from more than one switch. Absolutely, these are logical. So what can happen is this switch over here can have VLAN 1 and VLAN 2 ports. This switch over here can have VLAN 1 and VLAN 3 ports. And very simply, VLAN 1 traffic here can get processed by this switch, this switch, this switch, and this switch, and those two devices in VLAN 1 can talk to each other directly. No problem. It's going to go through these switches to get there, but it can do it. Meanwhile, if I have a node up here on VLAN 2 and it needs to talk to VLAN 3, well, VLAN 2 traffic is going to go to this switch to the router. The router will have configuration to say yes or no. If it's going to allow it, it's going to pass it back here and allow that to occur. But the rules could be here to say yes or no. That's why you're adding that in there. That's why that's in there as a checkpoint, if you will, if you have to use a descriptor there. So, my managed switch, when I go to configure it, I'm typically going to find on there some default VLANs, usually called the admin VLAN. This admin VLAN can't be deleted or renamed. It's there by default. And usually all the ports on the switch belong to that VLAN by default from day one, if you will. When I want to create VLANs, I take ports out of that default or admin VLAN and add them to the new VLAN I create. So I can, I create a new VLAN, VLAN 20, blah, blah, blah. I start taking ports out of this default admin VLAN and start adding them to this new VLAN that I created. That's what I end up doing. And it should look like this. Here we go. Here is a configuration from a switch. All of these ports here would be in default admin VLAN. I take those ports out of that pool, or these ports here out of that pool, and start applying them to VLAN 10, VLAN 10, VLAN 10. Here's a couple applied to VLAN 20, and so forth. So the ports by default are in the admin VLAN right here. Here's the default admin VLAN. The ports are in there by default. When I create a new VLAN, I grab them out of that pool and start putting them into VLAN 10 here or VLAN 20 here. All right, that's what I do. That's typically the operation I do. They also say, hey, on managed switches, I run into two different types of ports, access ports and trunk ports. Absolutely. So on a switch, a workstation, a printer, a IP phone, an access point would all be an endpoint that would connect into, most likely, an access port. A computer connected to an access port doesn't know which VLAN it belongs to. It's connected. The switch is the one that says, yeah, you're VLAN 10, you're VLAN 20, and the switch processes that for that. So the access port is just, you're saying, hey, this node I'm going to put in blah VLAN. So if I take a look at the config I showed you earlier, here is Fast Ethernet 01 port. That we're saying actually belongs to switch port access. There it is, access port VLAN 10. We're saying it belongs to VLAN 10. The node plugged into it has no idea, but the switch knows. Switch knows, hey, any traffic coming in from there is going to belong to VLAN 10. I also have another port called a trunk port. The trunk port, and you notice in this case it's just one. I can do one or two, but I normally don't need many. The trunk port is designed to connect this switch to another switch or another router. So it's usually between your networking devices. Your trunk port gets used. This is there to manage multiple VLANs. And the name actually comes from back in the phone days where you had a phone trunk between a residential house and the CO back at the office. So this port here is really designed to take the traffic from the whole switch and connect it to another switch or another router. That's what it's there for. And again, trunking, that trunk name comes from the telephony field, the old days of phone. You had phones out here. They connect into a local distribution frame, all phones in the neighborhood, and then they would use a trunk line from here back to the central office. That's what they would do. That's the name trunking is coming from. On a switch, that trunk port, okay, all of these VLAN 1 and 2 access port devices plugged into here, all of that traffic is going to get trunked up here to the switch and the router. So this port here on the switch, this port here on the switch are going to be trunk ports, including this one here on the switch to the router are going to be trunk ports. And what that really means is it's going to take all the traffic coming from the switch, pass it across that port, tagged as to which VLAN it came from, whether it came from VLAN 1 or VLAN 2, run it up here, and the router would say, yeah, let the traffic go, or no, don't let the traffic go. So a trunk port is really a way to move traffic from switch to switch or switch to router, but when it does it, all the traffic coming from VLAN 1 is going to get a luggage tag on saying VLAN 1. Anything coming from VLAN 2 is going to get a luggage tag on saying from VLAN 2. There's the frame tag. The IEEE 802.1q frame tag is going to get used on these trunking ports. And that allows the neighboring switch to read it and say, yeah, I'll pass it on, or no, I won't. And also the router to read it and say, yeah, I'll pass it on, or no, I won't. That's what those frame tags are for. And that's from the trunking port. And here would be an example on the router of a trunking port. This, as you look down here, switch port mode shrunk. This gigabit port has been trunked. So it's going to take any traffic coming from these VLANs, frame tag it, and pass it out this port. That's what it's going to do. And then whatever's connected to it will start reading that and understanding it. Here would be an example of what I would do for trunking. If I have, in one of our hack buildings, I have a switch on the first floor that has access points, phones, and wired users in it, in VLANs, into the switch. What I can do is I can trunk that to another switch. I actually trunk port here, trunk port here. I trunk to another switch. So traffic coming from wired VLAN 10 here, when it moves to this switch and this one, the switch say, oh yeah, I'll let these guys talk to each other. Or these phone traffic here come up here. Oh yeah, I'll let those phones talk to each other. That's what that allows. So now if I have multiple switches scattered around the building, anything in VLAN 20 phone can talk to any other switch VLAN 20 phone, allowing me to call anywhere in the building. When you think about it that way, it makes perfect sense. That's why I would trunk my switches together, and I would keep my VLANs the same numbers on all the switches. That way phones on floor 1 can talk to phones on floor 2, floor 3, floor 4, etc. And that's where this logical arrangement comes from of VLANs. Things can be scattered anywhere. I can trunk my switches together and it acts like one big massive switch then, and all the devices in the appropriate VLANs can talk to each other. I can also have my switches communicate their VLAN database to each other using VTP. VTP is a protocol that Cisco has that allows you to take a VLAN database on this switch here and share it with other switches. That's what that really allows you to do. So if I have a VLAN database on the server switch up here, I can say, okay, all these client switches copy me. That way you have the same VLAN database and you have the same VLAN 10, 20, and 30 that I'm using. And that allows me to configure one switch here and the other ones go along for the ride. So if I do have a large switch infrastructure, I can configure this to kind of reduce my config load. That's what I can do. That's your VTP, Cisco VTP protocol. And you notice I'm making this very deliberate, used to copy the VLAN database on VTP server to all the VTP client switches. Okay? And the reason I'm doing that is this name is very misleading. VTP, the name is very misleading. That's why I'm telling you everything I can before I actually say the name. VLAN trunking protocol is not what is used for trunking that we just got done talking about right here. That is what's not getting used across the trunk port. It is simply there to replicate VLAN tables between switches. Okay? So don't let that one confuse you. When we talk trunking, what is actually occurring is this frame tag that we mentioned, I think way back here. Where was it? Back there. IEEE 802.1q tag. That is what's getting used to identify VLAN traffic across trunk ports. And the trunk ports read those frame tags to know what to do with that traffic. Okay, so don't let that guy confuse you too much. Last section here, they say, okay, let's start putting these VLANs and subnets together. So normally in a network, we often see VLANs and subnets together working in tandem. Yeah. So if I take this example back here that they had, let me go back a little bit further. Where are you? Where are you? This guy right here. And I start putting VLANs and the IP scheme on top. What I actually start seeing is, okay, let me zoom back here now. What we actually start seeing is, okay, the VLAN traffic here on this switch, VLAN 1, VLAN 1, VLAN 2, VLAN 3, that's a layer 2 thing. But I do eventually need IP addressing for the nodes attached to it. So now we superimpose a subnet on top of it, and I say, okay, well, VLAN 1 devices are all going to get IP addressing from subnet 1. That way they're all in the same layer 2 and layer 3 part of the network. And VLAN 2 is going to get addressing from subnet 2. That way they're in the same layer 2 and layer 3 network. VLAN 3 is going to get subnet 3. That way they're all in the same layer 2 and layer 3 network. And this configuration then between the switches is trunked, so everything's frame tagged, and then from the switch to the router is also trunked, and then we configure the router up here to recognize those 3 subnets. That's what actually happens. And to do that, what actually happens is that router port, that physical router port, is broken into 3 logical ports. They call them sub-interfaces. We're going to do this in lab as well. We're going to take that physical port, break it into 3 logical ports. And I think I have it broken out here for you here. Yeah, I have it broken out for you here. I'm going to take that port, a physical port, and break it into 3 logical ports. So VLAN 1 is going to get subnet 1, and we're going to call it subinterface 1. VLAN 2 is going to get subnet 2, subinterface 2. VLAN 3 is going to get subnet 3, subinterface 3. That's what we're going to do. And that way that port will recognize layer 2 and layer 3 information coming in that port. Network admins follow the simple rule of basically 1 broadcast domain equals 1 VLAN equals 1 subnet. All those kind of go together. Other things can be done, but that's kind of a good rule of thumb to kind of stack everything up and make it all work together. And that is accomplished with the subinterface thing I just showed you. So let's take a look at that a little bit further. If I take an example, take their picture here and add just a little bit more information to it. For VLAN 1, I'm going to configure on the router subinterface 1 to recognize VLAN 1, and I'll assign it subnet 1 or assign it something like 192.168.10/27. That's 3 bits borrowed. 3 bits borrowed is 128.64.32 going up by 32s. So the first 32 numbers would be subnet 1 for VLAN 1 on subinterface 1. VLAN 2 is going to get subinterface 2 on the router, subnet 2, 192.168.32. And then subinterface 3 is going to get VLAN 3 traffic, subnet 3.64. So that is actually how that would get done. Those VLANs and IP addressing schemes stacked on top of each other. And again, this is very normal, used frequently. We are going to work our way up to this in lab. We'll do VLANs and we'll do trunking. Then we'll do the sub interfaces so we can do inter-VLAN routing is what we're really going to do. We're going to put all these pieces together for you. That's how it starts looking. And now I can actually have VLAN 10 traffic here go to the router, VLAN 20 traffic here go to the router, and if I want to, the router is going to allow those two to talk to each other. But this traffic here is literally going to go to the router before it goes over here to these nodes. And that's called inter-VLAN routing. That's what that's really called. Last thing they mention is types of VLANs. I do have default, native, data management, and voice. Default is the one we said before. It's on there. All the ports are in there by default. Just like this right here. All the ports are in there by default. All the ports are in there by default. Okay. Native, this receives all untagged frames. By default, this is the same as the default VLAN. To protect the network from unauthorized access really should not be used. Things should be put into some kind of VLAN. That way there's nothing sitting there or can accidentally get in there, if you will. Data VLAN is there to carry data traffic, user, workstation, that sort of thing. Management, this is used to get access to the switch remotely. Okay, I would use a management VLAN on that, maybe 1 or 2 ports. And voice VLAN is there to handle voice traffic. And what we see here is, I showed you an example of a configuration from a voice network. This particular port actually has 2 VLANs assigned to it. Access for the data if a computer plugs in, and voice for the phone when the phone plugs in. So it would recognize either one of those, and that's where that voice or voice over IP VLAN comes into play. We'll end up doing that in our voice over IP lab as well. I can see my VLANs by looking at the show VLAN command. or the show run command. One of the two will do it. There's the show run, showing all the VLANs, ports and their associations, and also the show VLAN right here.